In the last class or in the previous session, we have tried to learn what is main memory and what are the different techniques that we are utilizing to reduce the effect of delay in accessing main memory. So in this class, we will be studying different techniques that we are going to use so that we can effectively save our memory. Okay, the first thing what we are going to study is called as paging. What is meant by paging? So paging is a memory management technique that needs, see last class we have seen contiguous allocation of physical memory. That means whenever you need a requirement, that particular portion of the memory is being allocated for a particular process. This kind of allocation is not required when you are using paging. In paging, what we are doing is that we are dividing the entire logic memory into different pages, and each page is assigned what is called as a frame in physical memory. So logical memory is accordingly divided into pages, and each page in a physical memory is saved as a frame. You have a page, and this page is connected to what is called as a frame. This is in the logical memory and this is in the physical memory. So the next point what we are going to see is that how paging works. Okay, when the process is executed, its pages are loaded in any available memory frames. Okay, and a page table, there is a page table created, and this page table will have links to all different frames. This works like an index. There is an index page, in your books you can see that you have an index page. If you want to do something or if you want to search for a particular topic, what you can do is that you can go to that particular page from the index so that it is very easy for you to search. The same way, we have a page table which is going to act like an index. Okay, and this index is going to match every page to a particular frame. Page is a space in the logical memory, and frame is a space in the physical memory. Okay, so you have logical memory, physical memory. Logical memory, you have connections to the pages, and each page is connected to a frame in the physical memory. Okay, size of the page is equal to the size of the frame, ensuring that there is no internal fragmentation within the frame. So what are the advantages? See, these are the very common questions that appear in your exams. Why do you want to do paging? What are the advantages of doing paging? Or what are the problems that might occur? What are the disadvantages of paging? So now I can diagrammatically show you how a page works. You have a page table here, you have a logical address, you have a physical address. Okay, so this page table acts as an index. This page table acts as an index of which process should start at which point. Okay, This page table will be getting connected to this thing, and you have a physical memory here. This is how a page works. We have so much advantages, that's why we are working with pages. Memory is a very valuable resource. So how effectively you can utilize your memory resources is of great concern for all of us. So it's explanatory, right? You want more explanations on this? Do you want any more explanations on this? So the next concept that we are going to study is segmentation. So segmentation, like paging, is another memory management technique where you are dividing the memory of the process into a flexible kinds of segments. In pages and in contiguous memory allocation, all these things, we had only a static memory allocation. Static memory allocation means a fixed size. This cannot vary. In segmentation, the advantage is that we are creating different segments of varying sizes according to the requirement of the process. So what happens when we are adjusting that? We are reducing wastage, right? So this is based on the logical divisions of the requirements of the program. So in paging, we call this to be a page, and we had frames. Here we have segments, and each segment has a particular name and a length to identify the segment. Okay. The operating system maintains a segment table for each process. Each table entry contains what two things. One is called as the base, the other one is called as the limit. Base is the starting physical address of the segment and the length, so that you can calculate what is the length of the segment, each segment, right? So as I told you, segments are of different sizes. You don't have to remember, you don't have a fixed size allocations. You have variable size allocations. So two things you need. One is a name there and the length of the segment. What are the advantages and disadvantages of segmentation in operating system memory management systems? Supports logical division of a program, more user friendly, provides better protection and sharing of different segments, and can have different permission. The most important thing is that it is more effective, very simple, because of its variable length structure. Okay, disadvantages means you have external fragmentation that might not look that nice. Okay, since the segments are of variable sizes, you need to have additional things to be done. Okay, and the next thing is it is a bit more complex, in arranging and rearranging. You don't have fixed lengths. The lengths keep changing. So, okay. Next important concept is what is demand paging. So what happens here is that in demand paging, what we are doing is that we are loading into the memory only those pages that are. So here, what we are doing is that we are we are using only those pages that are in need. Whichever wants memory, only that will be used. Okay, that is called as demand paging. The others will remain in the disk. Okay. So how this process So this is how the demand paging works. Okay, these are the steps. One by one, we'll be seeing what it is. Only a small portion of every process is being first loaded, not the entire process. Okay, and the I mean the CPU requests for the processor requests for a page. If the page is in memory, then it's a normal access. Otherwise, not in memory, a page fault occurs. So from this we will understand what is the concept of a page fault also. So when the page is not in memory, what happens is that you have a fault that occurs. In that we have two conditions. Okay, so it checks whether it is valid or not. Once it is valid, then OS loads the page from the disk to the RAM, and then it updates the page status or the page table, and then it restarts the instruction that caused the particular fault. Otherwise, the second option is that it is invalid. Okay, if it is invalid, a segmentation fault or an invalid memory access error is being raised. Okay, so in demand paging, what we are doing is that we are not loading the entire thing. We are giving the process which has higher priority the demand, whichever has a demand, that particular process is being picked up and is being processed. Okay, what is meant by page fault? So a page fault occurs when a program tries to access a page that is not currently available in the physical memory. Okay, there are three types. One is a minor or a soft page fault. The other one is major, and the third one is invalid page fault. The page is not in the RAM, but it is still mapped to the swap page and can be loaded quickly. This particular thing is called as minor soft page fault. Okay. Now major means the page, okay, must be loaded from the disk, which is much slower. It is not in the queue. There is no process that waits for it. Okay. The third one is that there is no such page at all. The page access itself is illegal. So these are the kinds of faults that might occur in demand paging. Page faults. Next point is that you can expect this question in your exams. Almost in every exam you will get this question, regular question. What are the different segmentation algorithms? Or what is page replacement algorithm? Very common question, and explain different algorithms that are being used for page replacement. So page replacement is nothing but swapping. Okay, whichever page is required, one after the other, it has to replace, right? So that the processor is effectively utilized. Okay, you have a backup storage, and from that storage to the main memory, you access the page and you give it back. Once the process is over, you give it back. This swapping is done by checking the contents of the physical memory. If there is a free frame in the memory, then what we do? We swap in the required page to the frame. Okay. Frame which is then processed. The first algorithm is very simple. First in, first out. The oldest page is the first one to come in and it's the first one to go out. Okay, the oldest page in the main memory is the one which will be selected for replacement. Easy to implement, very easy procedure. This is the first algorithm. And we keep a list of all the pages that we need to replace. The first algorithm that we are studying on page replacement is first in, first out. The second type of algorithm is least recently used algorithm, or the one that is not at all used. Okay, that will be taken and replaced so that the processor is effectively utilized. The pages that is not very frequently utilized. First one is that whichever is the first one that came in, that is being out. Sometimes the first one that came in might be the one that requires more time for processing. So in that case, first in, first out might not be very suitable. This another next one is the least recently used. Okay, takes a list of all process that is being done recently, and the one that is least used is being replaced. Optimal OPT, the next type of algorithm. Okay, that means you are optimizing, that means you are using the one that is not being used for a long time in the near future. The time for is considered, not the frequency. Frequency is the number of times a particular page is being used. Okay, the previous one, it was the least recently used one, and now it is the optimal OPT. Least frequently used. Something that is more familiar to you than least recently used. Okay, least frequently used, lowest frequency access. Okay, so what is virtual memory? Virtual memory is a very important concept in operating systems. Virtual memory is a memory management technique that allows the programs to use more memory than physically available RAM by taking a portion of the other external storage devices and considering that to be a RAM. Okay. Physical memory is managed behind the scenes and the programs don't need to worry about what how this switching process is happening. So how a virtual memory works? What are the important stages? First one is the address translation. The programs use virtual addresses. The second stage in this virtual memory is that it, it divides the whole process into pages or segments. Okay, this is called as segmentation. Then page replacement, swap space. When the RAM is full, what happens? You need to remove one thing and place something else on that. No, this is called as page replacement. We have seen page replacement algorithms in the previous slides. Okay, that is page replacement. The final one is called as the swap space. Okay, a dedicated part of the disk where you have this stored is called as the swap space. What are the advantages of using virtual memory? Naturally, memory is a valuable resource. You have a You have a larger address space, you have more memory to be used, you have multi-programming support, you have memory protection, isolation and stability makes programs much easier, efficient memory use. So these are the basic advantages of virtual memory. Thank you all. Thank you very much.